Friends, in this video, I will be talking about a topic called as branch and bound. This is with respect to the subject analysis and design of algorithms, and the subject code is BCS 401. This comes under the fifth module of the subject ADA. Okay, so the topic is branch and bound. Before I go to the textbook definition, let me explain this with the help of a real life example. Okay, see, in case of branch and bound, there are several steps. Okay, one is branch, obviously. Then there is one more step called as bound, and there is prune. These three things are there: branch, bound, and prune. Branch means explore. See, branch it. Okay, so for a tree, there will be different branches, right? That means different possibilities. Okay, so remember, branch means different options or different possibilities. Different possibility. And bound means like a factor that limits the options. Like you can't go with all the options, right? You might have to go through one of the ways or one more than one way. So this will divide that. So this will decide that. Okay, so factor that limits the options and suggest you which path to take. And whichever path you're taking, that is fine. The other paths which are not required, other paths which are not required can be removed. Required are removed. Okay. So three things: branch, bound, and prune. Now let me take an example of a flight booking. So let me book a flight from Mangalore to Delhi. I'm booking a flight from Mangalore to Delhi. So branch means I will explore all the options. Maybe one path is Mangalore, then to Bangalore, and then Delhi. Maybe another way is Mangalore, Chennai, and then Delhi. And let's say the other option is Mangalore, Jaipur, and then Delhi. See here, I'm exploring the options. So that comes at a branch part, and then bound factor. So bound factor means I will decide on a factor that will make me go through a certain way other than exploring all the branches. See, in this case, the bound factor is, let's say, the cost. Okay, so for this particular path, the ticket price is, let's say, 5,000. Okay, so suppose this path is 10. So what I will do is, based on this bound factor, I will leave off all the other paths which are lesser than the which is more than the bound factor. See, if there is a solution, okay, right now I have a solution and I'm going and exploring the other options. If the other options is worse than my current solution, then I will leave it off. That leave it off part is prune. But based on the bond factor only, I will then go ahead. Right. So, for example, if this particular path, let's say, is 3,000, this is all hypothetical values. So, see, this is a current solution. So, with respect to that, this will be removed or pruned. Whereas this option is better than the current option. So, this path will now be explored. We will prune this particular path. So that is branch and bound. When the options are available to you based on the bound factor, you will leave off those options that are not feasible for you. Okay. So we'll look at the definition of this one. See here. It is, if they ask you to explain this, you can explain with the help of this definition. So it is a problem solving algorithm used for optimization problems. Optimization problems means like finding the max, finding the minimum values, all these kind of problems. Okay. So, where the solution space is systematically divided or branched into smaller parts and unpromising paths are eliminated or bounded based on the estimated limits in order to find the optimal solution effectively or efficiently. See, we will be exploring the different branches, but while we are exploring, there is something called as bound factor which will limit our exploration. We might have different branches, but based on the bound factor, we will only go through some of the ways. This will lead you to ultimately to the final solution. And I told you there will be different steps. First is start with the initial state. So yeah, we'll start with the initial state. Then we will go to the branch step where we'll generate the next steps. Then bound. Bound means calculate the limit. Okay, so it will be either upper bound in some maximization problems, or in case of minimization problems, it will be lower bound. Then prune. Prune means if the bound is worse than the best solution, discard that branch. If the branch that you are finding right now is worse than your best solution, so you will leave off that branch. So leaving that branch is called as pruning, discarding. Then continue this until you explore all the promising branches and the best result among them is the optimal solution. Okay, so you will have to learn that. Now let us go to an example. So I'll take up an example and I'll show you how to do the branch and bound. This is an important question in the exam also. So you can understand this. So there will be item. See, but before that, I'll take up one example. Okay, so this branch and bound is applied on a knapsack problem. So what is knapsack problem? In simple words, if I have to explain, it is like a school bag. Okay, there is a school bag and school bag has a limited capacity. You can't just keep stuffing things into your knapsack, into your school bag. Now what happens is there are several books that you want to put because let's say you're going and going to the school tomorrow, so you're arranging the books according to the timetable. Now while you arrange, okay, there are some other books like story books or drawing books which are not required for your school, but you want to put it into your bag so that during your free time you want to read. Okay, but if you do that, because of the overstuffing of your bag, there is a chance that your bag will get torn. Now what to do? You can't live off the school books, and storybooks you don't want to live. Now what to do? Now, in case of this particular problem, you will have to prioritize which one is more important to you, and based on that, you put the things into the bag. See, in case of knapsack also, that is a thing. Knapsack is like a bag with limited capacity. You want to put things into the knapsack so that the capacity of the knapsack doesn't exceed. Okay, otherwise the knapsack will break, no? It has a limited capacity. So you can't go on putting the things. So you can put the things not exceeding the capacity. Also, if there are too many things, you put things which are having the highest value. Like in the school bag, though you want to put all the books, which book is actually very important for that class? The school books, right? So you will put that into the bag. So that is what knapsack is. See the problem here. Statement: given n items with the known weights wi and its value vi. Value means each product will have its value. Okay, and there is a knapsack capacity of capital W. Select the subset of the items that maximizes the value without exceeding the weight limit. Okay, so there will be an n items. Each item will have a weight and value associated with it, and knapsack will have a capacity of W. You have to go on putting things into the knapsack so that it doesn't exceed the capacity of the knapsack, and the value will be the highest for the items that you have added. And in case of branch and bound, this pre-processing has to be done. This is very important. See, Sort the items in the descending order of their value to weight ratio. Value to weight ratio. See, for example, if there are two items, okay, I'll take one item. Its weight, let me say, as 2. And let's say its value is 50. Likewise, there is second item whose weight is 4 and its value is 30. Okay, this is weight and this is value. Now you will have to find V by W ratio for each of them. V by W. So 50 by 2. V over W. So this becomes 25. And for this one, if it is 30 by 4, so it will be, so 4 times 7, 28, 2. So it is becoming 7.5. So like this. 7.5. So you'll have to find this ratio because this ratio only will help you get the bound factor. Okay. And you will construct using the state space tree. Yeah. Two options will be there. You will explore one of the paths based on the bound factor and all that. And this formula is very important. This formula. You will find the upper bound. So upper bound is the value and the total weight of the knapsack or the capacity of the knapsack, then the weight of the current item plus Vi plus 1 and Wi plus 1. See, Vi plus 1 and Wi plus 1. See, I have taken the initial value is V, but here I have taken Vi plus 1. See, for the current item, ratio will be taken of the next item. Suppose you are considering the first item. If you're finding the upper bound for the first item, then value over weight ratio will be considered for the second item and so on. Okay, so if you're considering fifth item, then the value over weight ratio will be considered for the sixth item. That is how the formula goes. I hope that you have understood. Now let us look at the problem. This is example 1. Okay, so 4 items. 4, 7, 5. Once you understand the steps, then for any problem you will be able to solve this. So 42, 25 and 12. This is your problem. Let us start with the solution. Step 1. That is arrange the items in the increasing order of their value over weight ratio. Increasing order of value over weight ratio. Okay, what I will do is I'll calculate over here. See, I'll do here value over weight ratio. So 40 over 4 is 10. 40 divided by 4. So 42 divided by 7 is 6. Here 25 by 5 is 5. And 12 divided by 3 is 4. Okay. Next, you have to arrange them in the decreasing order of their value over weight ratio. See here, the items are already in the decreasing order of their value over weight, right? So 10, 6, 5, 4, it is in the decreasing order. So you don't have to do anything, luckily, in this particular step. So you write it as it is. So item, weight, value, and V over W. 4 items are there. So 1, 2, 3, and 4. 4, 7, 5, 3, 40, 42, 25, and 12. So these values are 10, 6, 5 and 4. Okay. Now let us go to the step 2. Step 2 is constructing the state space tree. I'll use another color just to show the different step. Step 2, construct state space tree to obtain the solution. Okay. State space tree means initial state will be there, then there will be branching, then going to a particular path. Okay, so initially, let us start with the solution. So initially, you have to find the upper bound. Okay, you have to find the upper bound. So for upper bound, if you remember, upper bound formula is this. Uh, Upper bound is value plus total capacity of the knapsack minus the weight of the item times the ratio of the next item. This is the formula. Now, see, if it is initial state, see, there are 4 items. Okay, first item, that means first, second, third, and fourth. Initial item means it is not coming under any of them. So, W equal to 0 and V is equal to 0. Okay, now you calculate the upper bound. So, upper bound is, you calculate the upper bound. Upper bound is V is 0. So, 0 plus total capacity. Oh, capacity will be given to you. Okay. I forgot to write here. Capacity of the knapsack is 10. Okay. So, 10 minus weight of the current item is 0 times. See, I am at the initial state of 0th item. So, I should take the ratio of the next item. 0 means next item is 1. So, 1's ratio is 10. So, it is like this. So, it is 0 plus 10 times 10, which is equal to 100. Okay, so upper bound is 100. Let us go and build the tree now. So there are 4 items. So I will start with the first item. So I will include that item 1 with item 1 and without item 1. I'll check which will give me the better solution, and according to that I'll consider and I'll continue with the solution. And one more thing is, see, that I'll do it or I'll tell you when I finish this step. See, with the item 1. So, W is of the item 1. Item 1 is having the weight 4 and value is 40. Correct? Here it is. Here. Okay. So, upper bound is 40. That is your value. Plus total capacity is 10 minus weight of the current item is 4 times value over ratio of the next item. Because I'm considering the first item, value over weight ratio will be of the second item. So this will be considered. So 6. Okay, so it will be 40 plus 6 times 6. You will apply the BODMAS rule. So it will be 40 plus 36, which is equal to 76. So upper bound is 76. Okay, let us do the other side now. See, it says without item 1. So without item 1 means what you have to do. Remember, when you have that without option, you will have to consider the weight and value of the previous item that was considered. See, this is item 1. So I'll consider the weight and value of the previous item, that is 0th item. So its value is 0, previous item, and value is also 0, correct? So upper bound is 0 plus, that is your value plus total capacity 10 minus value of the current item, so weight of the current item 10, 0 times ratio of the next item, because you're with the now you're doing for the first item without also, but it is for the first item, right? So you will consider the weight over ratio of the weight over value over weight for the next item. So it will be 0 plus 10 times 6, which is equal to 60. So upper bound is 60 now. Okay, upper bound is 60. Now you will have to prune one of the branches which is not required and continue with the one that you require. Now, what to do? Which one to choose? See, when I took that example of Mangalore to Delhi, I chose the bound factor to be the one with the cheapest ticket fare. Here, in case of knapsack, what I will do is, okay, see, knapsack means what? You want to maximize the profit, right? So, maximum, this is a maximization problem. So, I will choose a path with the maximum value. Whereas that problem of finding the ticket, there I wanted to find the cheapest fare, that is finding the minimum. So, there it was minimization problem. So, there is maximization problem and minimization problem, correct? So, this one, knapsack, comes under maximization problem. Minimization problems are those traveling salesman problem or finding the shortest path, all that. So here, in this case, I will choose the one with the path with the highest value and prune the other one. So without item 1, I will prune it. So I will go ahead with this path. Here again, I will try to find with the item 2, now next item, right? So with the item 2 and without item. So this one, I think you are now able to understand. Without means what? Without means I don't have to include item 2. So value and weight will be of the previous item. So V equal to 40, W equal to 4. So upper bound is value, that is 40 plus total capacity is 10 minus weight of the current item times. So because this is item 2, you will consider the weight of item 3. Next weight, no? Sorry, next ratio, right? So next ratio is this one, this 5 value. So this will become 5. So it will be 40 plus 6 times 5. So 40 plus 30, which is equal to 70. So upper bound is 70. Likewise, with the item 2. Now here, there is a special step or special consideration. See, when you're considering the knapsack, okay, knapsack means putting several items. See here, I have already put, when you're considering this particular path, see here, when you're considering this path, see, item 1 has gone into the bag. Now, item 2, item 1 is already in the bag. Remember? Item 1 is already in the bag. So, you are supposed to calculate by considering that item also. See, weight means, see, previous item is already there. See, see, previous item is already there in the bag. Now you are adding the next item. So, next item is having the weight as 7 and the value as 42. So, 7 and 42, right? So, it will be like this. So, previous items, because I've included the item 1, no? So, 4 plus 7. So, it becomes 11. Correct? See, one more thing is, do you think this is a feasible option? See, what is the capacity of the knapsack? Knapsack capacity is 10. What is the weight? I'm getting 11. Do you think this will fit into the knapsack? No, this will not fit because 11 is greater than the value 10, right? So you can say that this is not a feasible option. This is not a feasible option. So out of the two, now I will consider this path. One is not feasible only, so there's no point in considering that path. So I will go ahead with this one. So again, next item. So with the 3, without 3. Okay. With the 3, without 3. So without 3 means you have to consider for the previous item. So W equal to 4 and V is equal to 40. Only the ratio will change. So upper bound is 40 plus total capacity 10 minus 4 times the ratio is, see the ratio is, we are considering for the third item. Okay, so this is item 3. So the ratio will be of the fourth item, that is 4. Because this is third item, ratio will be of the fourth item. Next items, right? So this will become 4. So it will be 40 plus 6 times 4. So it will be 40 plus 24, which is equal to 64. So upper bound is 64. Now let us consider width. Okay, let us consider width. See, remember, item 1 is there. Now, without item 2, so item 2 is not included with the item 3. So, item 1 and item 3's weight should be included. So, item 1 is 4 and item 3's weight, wait, let us consider item 3. Item 3 is 5 and 25. Okay, its weight is 5 and value is 25. So this will be 9. 9 is still lesser than 10. So both the items can go into the knapsack. So this is a feasible option. And value of the first item is 40. See, value of the first item is 40 and current item is 25. So you have to consider both. So value is 40 plus 25, which is equal to 65. Okay, now let us calculate the upper bound. Upper bound is value, that is 65 plus total capacity of the knapsack is 10 minus the weight of the item is 9 times the next ratio is 4. Okay, so it will be 65 plus 1 times 4, which is equal to 65 plus 4, which is 69. So the upper bound is 69. Now out of the two options, which one is better? This option is better because that is having the greater value. So I will continue with this. So with the item 4 and without item 4. Okay. Now with the item 4. See here, you are following this path. So item 1 is included. Look very carefully. Item 1 is included. Item 2 is not included. Item 3 is also included and item 4 now. Item 1 is included, so it was 5, its weight was 4. Item 3 was included, so its weight is 5. Now the current item 4. Item 4 is having the value and weight as 3 and 12. So I will try to put that into the knapsack. So 3. So this becomes 12. Now what are you supposed to do? If you've understood the step, you should be able to tell me. This is not upper bound, sorry. This is not upper bound. This is weight. So capacity is 10. Weight of the total item is becoming 12. So this is a feasible option or not? This is not a feasible option because it is greater than the capacity itself. So this becomes not feasible. Correct? What about the other side now? So it will be of the previous item. Previous item is having the weight as 9 and the value as 65. So upper bound is 65 plus total capacity 10 minus the weight of the item 9 times. Now, because this is the last item, what do you think should be the value over weight ratio? See, for every item, we are considering the previous item, right? But here, this itself is the last item. So, what will you consider? Because this is the fourth item, there is no fifth item. So, which ratio will you consider? In this special case, when you are coming to the last item, you will have to consider the weight over the value of the weight of the current item itself. Say I'm at item 4, right? So I will consider its ratio only. Why its ratio? Because it does not have any other ratios, right? Fourth item, ideally you should have taken the ratio of the fifth item. But because fourth item itself is the last one, so I will consider the value over weight of the current item itself. So that is 4, see. So I will go ahead with that particular path. Okay, so I will calculate for 4. So it will be 65 plus 1 times 9, which is 1 times 4, sorry. So it is 69. So the upper bound is 69. So this will become the solution, correct? Now you will have to look at the total path. See, total path. I will highlight this. See, I have started from here with the item 1, then without item 2, okay? With the item 1, without item 2, with the item 3, and without item 4. So, there were 4 items. See, you have to write this step, okay? You have to write this step. So, the values are, there are 4 items. See, 1, 2, 3, and 4. Remember, remember, first item was chosen with the item 1, right? With the item 1. So, this will get the value 1. And this is second item is not chosen because it says without item. So, this becomes 0. Item 3 is chosen. So, this becomes 1. Item 4 is not chosen. So, this becomes 0. And the subset is the one element that are chosen. Okay. So, the subsets are item 1 and item 3. This will give you the highest profit if you choose item 1 and item 3 into the knapsack. I hope you have understood. So you can take a screenshot of this and then you can do the problem and check. So step 1 and step 2. I hope you have understood. Let us look at one more problem. Now, I have taken one question from your model question paper. Let's see if it is there. Yeah, the model question paper. There is one problem with respect to branch and bound. See here, branch and bound problem. So 10b, using the branch and bound technique, solve the below instance of the knapsack problem. They've given items, weight and value, and they've given the capacity as 5. And this question is coming for 10 marks. So very important question. So let us solve this question so that you will be able to do it comfortably if it comes for the exam also, or a problem similar to this. So first one is, let's write the question itself. Okay. So item is there, then weight and value. So 1, 2, 3, and 4. Again, 4 items. Weights are 2, 1, 3, 2. Values are 12, 10, 12, 10, 20, and 3. Sorry, not 3, 5. This is the data we have. Let us first do V by W so that we can arrange them. So 12 by 2 is 6, correct? 10 by 1 is 10. 20 by 3. So 20 by 3, 3 times 6, 18. Reminder to put the decimal point. So 6, again 18. Okay, so I'll take it as 6.66. And 2 by 5 is, sorry, 5 by 2 is 2.5. Okay, this is the data we have. Now let us start the calculation. So step 1, so arrange items in the decreasing order of V over W ratio. So item, weight, value, and ratio. See, this is the first item that will come because it's uh, value over W is the highest. So this will come first, followed by this one. This is third, and this is fourth. Okay, so let us start. So item 3 will, sorry, item 2 will come first. So 2, 1, 10, and 10. This will come first, followed by third item. So 3, 3, 20, 6.66. Next, first item will come 2, 12, and 6. And the fourth item will come. So 4, 2, 5, 2.2. Like this. Now let us start building the state space tree, step 2. So step 2, construct the state space tree. Okay, let us start. Initially, it will be like this. So 0th item, so W equal to 0 and value also equal to 0. So upper bound is, oh sorry, capacity again I forgot to give you. In the problem, they have given the capacity capital W to be 5. So upper bound is, formula should I write? Upper bound is V plus capital W minus small w times V of I plus 1 over W of I plus 1. This is the formula. So value is right now 0 plus total capacity is 5 minus weight of the current item is 0 times, because it is 0th item, I will consider the weight of the next item. See here, I have to go with this order only. Okay. Though for 0th item, the first item should be considered, but you'll have to go with this order. So I'll consider this 10. Okay. So it will be 0 plus 5 times 10, which is equal to 50. So the upper bound is 50. Like this. Next is Now you'll have to go with this order only. So first with item 2, then without item 2. With item 2, then without item 2. Okay, without item 2. So without means previous item only will be considered. So W equal to 0 and V equal to 0. So the upper bound is 0 plus 5 capacity minus the current item 0 times item 2. So item 2. So next items ratio will be considered. So it will be like this. So this is 6.6. Okay, it will be 6.6. Because this is for the next item we'll consider, right? That is why it is 6.66. So it will be 5 times 6.66, which is equal to 33.3. So this value becomes 33.3 upper bound. Let us consider width. So here if you consider its weight is 1 and the value is 10. See for item 2. So weight is 1, value is 10. And this V over W ratio will be for the next item. So for with the item 2, so I'll have to consider for the next item 6.66, right? Okay, now calculate the upper bound. Upper bound is 10 plus total capacity 5. Current item is having the weight 1 times 6.66. So this value is coming to 10 plus 4 times 6.66, which is coming to 36.64. So here the upper bound is coming to 36.64. Write neatly. So upper bound is coming to 36.64. Next item. So this option will be chosen. One side is lesser, right? So next item is item 3. Item 3. Its value and weight is 20 and 3. So we'll consider that. Okay. So it's item 3. So with item 3 and without item. Okay. Without is particularly easy. So without means previous value only and weight. So W equal to 1, V is equal to 10. So the upper bound is 10 plus total capacity 5 minus 1 times the ratio of the next item. So if it is third item, then I'll have to consider for the next item, its ratio is 6. So 6. 10 plus 4 times 6 is equal to 34. Upper bound is coming to 34. Now with the, so W is for the weight, third item, it is 3 and 20. So 3 value is 20. Okay. So upper bound is 20 plus Total capacity 5. Okay. But the thing is, here in this case, what are you supposed to do? One small correction. Can you tell me what is the correction you have to do here? Because I've included item 2 and now item 3. So item two's weight also should be considered. So 1 is already in the bag. This one is having the capacity as 3. So that also should be considered. Similarly, for the value, previous item is having the value 10 and this item is having the value 20. So that also should be considered. Why it should be considered? Because it says the previous item is inside the knapsack. So that also should be considered. Okay. So it is not 20, it should be 30 here. So it is 30 plus 5 minus 4 times. This is item 3. So next capacity. So 6 will be considered. So 30 plus 1 times 6, which is equal to 36. So upper bound is coming to 36. Let us move to the next option. This is item with item 1, without item 1, with item 1, without item. So it goes like this. If it is without, then previous weight only and previous value. So upper bound is, value is not 4, value is 30. So upper bound is 30 plus 5 minus 4 times okay. For the previous item, so we are talking about this is with respect to item 1, right? So for item 1, you'll have to consider the ratio of the next item. So 2.2. So 2.2 or 2.2, 2.5. 2.5. So this will become 30 plus 1 times 2.25. 2.5, sorry. So it will become 32.5. So this becomes 32.5. Let us go to the other side. So with item 1. So W is, check if any previous item is inside the knapsack already. So with item 2, this path, with item 2, with item 3. Okay, now we are coming to this particular path. So item 2 is already there. Item 2's capacity is how much? Item 2's capacity is, sorry, weight is 1. So 1 is already there in the knapsack. Next item, it had the weight 3. Now if I include weight 1, item 1 is having the weight as 2. See, value is 12, weight is 2. So 2. So this becomes 6. Okay. And what is the capacity of the knapsack? Capacity of the knapsack is 5. So this will exceed the capacity. So you can say that this is not a feasible solution. So you'll continue with the other part. So next option. So 2, 3, 1 is done. Now item 4. With item 4, without item 4. Without 1, I think is easy. So W is 4. B is equal to 30. So upper bound is 30 plus 5 minus 4 ratio of the current item itself, because there is no other item after it. So this comes to 32.5 itself. So upper bound is 32.5. Whereas in the other side, it is weight. So item 2 and 3 is already in the bag. So 3 plus 1. For item 4, what is the capacity and weight? Sorry, weight. For item 4, it is 2 and 5. 2 and 5, right? So that weight also should be included. So this also becomes 2. So it is 6, which is greater than 5. So this is also not a feasible option. So you'll consider this to be the answer. Now let us look at the path. So here, and this is the path. See, with the item 2, with the item 2, with the item 3, without item 1, and without item 4. So how will you write the final step? So the values are, so there is 2, 3, 1 and 4. This was the order, correct? These were the items order. So 2 was included. 2 was included. So here you will put 1. 3 also was included. So this is 1. Item 1 and 4 is not included. So 0. Okay. And the subset is 2, comma. So this will be the solution. I hope you have understood. First, you arrange the items in the decreasing order of their V by W ratio. Then you construct the space tree by using that formula of upper bound. Whichever is having the upper bound, according to that, you go on doing the solution. Okay. So branch and bound is a algorithm design technique in which you have branches, that is, you explore the paths, and then based on the bound factor, you limit your options. The limiter option is itself pruning, and you how the steps will go, continue, start with the initial state, then you do the branching step, then you do the bound step, then prune, and then you continue with the chosen path till you get the final solution. Okay, so I hope you have understood. Go through the problem also, go through the explanation. So explanation is also there, what to write if they ask you and all that. So you can go through that as well. So this one. Okay. Yeah. So thank you so much.